In the last lecture, we discussed about bus topology and star topology. Now let us see about ring topology. In this type of topology, each computer is directly connected to the other computers within the same network. Now as you can see on the screen, the network's data flows from computer to computer back to the source. The ring topology has a lot in common with the bus topology because if you want to add a network, you have no choice but to break the cable ring, which is likely to bring down the entire network. This is one big reason that ring topology isn't very popular. You just won't run into a lot as I did into the 1980s and early 1990s where this type of topology was popular. It's also pricey because you need several cables to connect each computer. It's really hard to reconfigure. Now let's say there are 50 PCs in the ring topology, and if you want to add a new PC, you just have to cut one cable, and that is why it would require a lot of time and that would bring down the entire topology. But even with that all being said, if you work at an internet service provider, that is ISP, you may still find a physical ring topology in use for the technology called Sonnet or some other WAN technology. However, you just won't find any local area network having a physical rings anymore. Also, since one computer goes down, ring topology is easier to troubleshoot, but as I said, it provides less fault tolerance because if one of the PCs goes down, the entire network ring goes down. Next ahead is mesh topology. Now in this type of topology, you will find that there's a path from every machine to every other one in the network. That's a lot of connections. In fact, I can tell you that the mesh topology can win the prize for most physical connections per device. You will never find a mesh topology in local area networks anymore, if ever these days, but you will find a modified version of it known as the hybrid mesh topology used in the wide area networks, including the internet. Now often hybrid mesh topologies will have quite a few connections between certain places to create redundancy. As you can see on the screen, there are 4 computers and all the 4 computers have their wires connected to other remaining 3 computers. Now from this we can sum up a formula. For each n locations or n hosts, you can have n into bracket n minus 1 upon 2 connections. In our case, there are 4 hosts. So let us put the value n is equal to 4 in the equation and we can get that 4 into bracket 4 minus 1 upon 2, that is 6 connections, and you can see on the screen that there are 6 wires in total. In mesh topology, there are a lot of connections. As I said, if there are 50 computers, then 50 into bracket 50 minus 1 upon 2, that is a lot of connections. Next, since there are a lot of connections, we require more number of wires and it's a pricey topology to install, and that is why mesh topology is not a common topology. But if one computer fails, we can troubleshoot it quickly because that computer's cables will fail and we'll get to know that this PC is not working. But apart from all of the advantages and disadvantages, we can see that mesh topology provides a robust fault tolerance. Even if one PC fails, the remaining network can communicate with other PCs. Whereas in the case of ring topology, if one PC fails, the entire network goes down. And that is why hybrid mesh topology is preferred these days in the internet. In the next lecture, we will talk about another 2 types of topologies, which is point-to-point topology and point-to-multipoint topology. Also, we will see how to select the right topology based on 5 to 6 factors, which I will be determining in the next lecture. Before moving ahead, I would like to tell you that if you are liking our lectures and if you're understanding it, we would like to request you to write a review and just share your experience with us. Your motivation is very valuable to us, and if you have any issues, Please feel free to type in the review and we will surely try to eliminate our drawbacks. I hope you will write a review and it just takes 30 seconds. I will see you in the next lecture.